Hello, today we're going to be talking about graphing other trigonometric functions. So far we've looked at graphing sine and cosine functions. Now we're going to have to look at graphing tangent, cotangent, secant, and cosecant. So the first thing we're going to look at is tangent. Now we've talked about tangent being sine of x over cosine of x. And so there's going to be times when cosine of x is equal to 0. You can't divide by a 0, so it's an undefined value. And so those undefined values are actually called vertical asymptotes on the graph. And so you'll see they occur at these like red dotted lines on here when cosine is equal to 0. So those vertical asymptotes are generally of the form pi over 2, or some version of that. So negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2 are found on the parent function. The y-intercept is still at 0, across the y-axis at 0, unless there's a vertical shift. This is just for the parent function. And you'll see that the period is from one vertical asymptote to the other. So this value right in here is actually the period, which it is. So if we have a change in period, that vertical asymptote's location is going to change as well. So that's what we're talking about right here. So the period, again, is pi over the absolute value of b. We kind of talked about that earlier, but this is where it's going to come into play a little bit more. So if you have the function y equals a times tangent of bx plus c, pi over the absolute value of b is going to be my period. So let's take a look at an example. It says locate the vertical asymptotes and sketch the graph of y equals tangent of 2x. So first let's look at our period. So we said the period is going to be pi over the absolute value of b. What's the absolute value of b? Well, in our example, b is going to be 2. So we get pi over the absolute value of 2. So what's my period? Pi over 2 radians. So now to figure out my vertical asymptotes, what I'm going to do is I'm going to take that bx plus c, or in our case, 2x plus 0. We don't need to write that though. But we're going to write 2x is equal to negative pi over 2, because that's in the parent function where one vertical asymptote is. And we'll look at the other vertical asymptote at 2x equals positive pi over 2. And so now I'm going to solve for x. So if you're trying to get x by itself, you divide by 2. Divide this by 2. Same over here, divide by 2. Divide by 2. And I find that one of my vertical asymptotes is at negative pi over 4. The other vertical asymptote is at a positive pi over 4. And you'll notice the distance between negative pi over 4 to pi over 4 is pi over 2 radians. So that's where the period comes into play. So what we're going to do is we have to make a table of values for our function. Now the parent function of tangent, the important values that I would put in for x would be negative pi over 2, and that's undefined. So that means it's a vertical asymptote. If you put that into your calculator, it would say error, or undefined. Okay, then the next value that's important to us is negative pi over 4, and that's where we get negative 1. Next would be 0. I get 0 from that parent function. Pi over 4 is positive 1, and then another pi over 2 is my other vertical asymptote. So that's the important values of the parent function of tangent. Now, for ours that we're just looking at, okay, we're going to put in our important values. Now you'll notice the vertical asymptote in a parent function is at pi over 2. Well, we found it to be negative pi over 4 for tangent of 2x. And so the y's don't change. It's still going to be undefined value. Same thing here, though. We also want positive pi over 4 to be my other undefined value. Okay? So that's my outside vertical asymptotes. Halfway in between them is 0. And so Same thing, halfway between my period before is also going to be 0. And so then I say, okay, well, what's the midpoint between negative pi over 4 and 0? Well, if you added them and divided by 2, you get negative pi over 8. And so that's my negative 1 value. Same thing on the other side, I'd get a positive pi over 8. And so that's a positive 1. So now that I have my important values, what I can do is I can sketch the graph of this. Okay? Alright, so here's negative pi over 4. There's negative pi over 8. There's 0. Positive pi over 8. Positive pi over 4. Okay, I can continue on. That would be 3 pi over 8. Then we have pi over 2. 5 pi over 8. 3 pi over 2. Excuse me, 3 pi over 4. 7 pi over 8. And then just pi again. Okay? So, if I'm going to put in my vertical asymptotes, okay? One vertical asymptote was at negative pi over 4. The next one was at pi over 4. Okay? And so now I can graph my points. Okay? So, negative pi over 8, I was at negative 1, so that'd be right there. 0 is at 0. Positive pi over 8 is at positive 1. So my graph is going to look kind of like that. Okay? Same thing. So, vertical asymptote, again, from the left side now, is where the bottom of my graph is going to be. So then I'd be at negative 1, at 3 pi over 8. Then I'd be at 0 at pi over 2. Then I'd be at 1 right here at 5 pi over 8. And you'll see that 3 pi over 4 then is going to be another one of my vertical asymptotes. And then I could just continue on. Okay? So that's my graph right there. Here's some examples right here. If you want to pause the video and try them, you're more than welcome to. Now, if we have negative tangent of x over 2, okay, we're going to do the exact same thing. First, we're going to find the period. Period is pi over the absolute value of b. Now, ours again, b, well, if you look right there, it's x divided by 2, which is the same as writing 1/2 of x. So my b is 1/2. So pi over the absolute value of 1/2, which is 2 pi. So now my period from vertical asymptote to vertical asymptote is going to be 2 pi in length. So to find those vertical asymptotes, remember we put bx plus c, which in our case is just x over 2, is equal to that vertical asymptote in the parent function. Same thing over here. X over 2 is equal to a positive pi over 2. Okay? So, how do I get rid of that divided by 2? I multiply both sides by 2. And I find that my vertical asymptotes are at negative pi and at pi. So that's where my vertical asymptotes are going to happen. So if I make my table of values, okay, I'll do it for the parent function first. Remember, normally my asymptotes happen at negative pi over 2 and positive pi over 2. Then there's 0 in the middle, negative pi over 4, and positive pi over 4. And my values, again, are undefined, negative 1, 0, 1, and undefined again. So that's of y equals tangent of x. But we are now looking at y equals negative tangent of x over 2. So, I'm going to make my table of values. Okay? We go from one vertical asymptote to the next with our halfway midpoints. Same thing in here. Halfway between negative pi and 0 is going to be negative pi over 2. And right here, halfway between 0 and pi is going to be pi over 2. Now, this negative right here says that I multiply all of the values on this side by negative 2. Or excuse me, by negative 1. So undefined by negative is still just going to be undefined. Negative 1 times negative 1 is going to be positive 1. Negative 1 times 0 is 0. And negative 1 times 1 is going to be negative 1. And this again will be undefined. So now what we have is our table of values for negative tangent of x over 2. So I can sketch the graph real quickly. Okay, my vertical asymptotes were at negative pi. I had a halfway point, which was negative pi over 2. And I had 0. I had a positive pi over 2, positive pi. And I can keep going on. So then this one right here would be 3 pi over 2. And that would be 2 pi right there. Okay? So, vertical asymptote. I had one at negative pi. And then I had one at positive pi. The important values, at negative pi over 2, I was at a positive 1. 0, I was at 0. And pi over 2, I was at negative 1. So my graph is going to look kind of like this, right here. And then if I repeated, again, it would start at positive 1, 0, and then over here at, this would be 5 pi over 2, that would be at negative 1. So it would continue on down here as well. All right. So let's look at another one right here. Now you'll see the difference in this one is now our C is different. B is 1, but C is different. So our period we're still going to look at, okay, is going to be pi over the absolute value of B. Well, what is B in this one? B is 1. So my period is still going to be pi, just like it was before. Now to find our vertical asymptotes, I'm going to take x minus 3 pi over 2 equals negative pi, because in the parent function, negative pi over 2, because in the parent function that's one of my vertical asymptotes. Then in the other one I have x minus 3 pi over 2 is equal to a positive pi over 2. Okay, so how do I solve for x right here? I'm going to add 3 pi over 2 to both sides. And so x is going to be equal to, well, negative pi over 2 plus a positive 3 pi over 2 would be 2 pi over 2, which is just pi. And then this one over here, if I added 3 pi over 2 to both sides, pi over 2 plus 3 pi over 2 is going to be 4 pi over 2, which would be then 2 pi. So that right there then is going to be my new vertical asymptotes. So if I look at the parent function of y equals tangent x, my vertical asymptotes were negative pi over 2, then I had negative pi over 4, I had 0, pi over 4, and pi over 2. And remember, my values were undefined, negative 1, 0, 1, and then back to undefined again. So now I'm going to be looking at y equals tangent of x minus 3 pi over 2. So all that's going to happen is I'm just going to go again from vertical asymptote to vertical asymptote. So that would be pi. And this one right here would be 2 pi. I find the midpoint in between them. So 1 pi plus 2 pi would be 3 pi divided by 2. Would be 3 pi over 2. And then halfway in between each one of those would be, this would be 5 pi over 4. And the next one would be 7 pi over 4. Okay, so those are my 5 values again. And now I can just plug in the same values. At pi, it's going to be undefined. That's one of the vertical asymptotes. Negative 1, 0, 1, and undefined. And if I know those 5 points, now I can quickly sketch my graph. So this is what my graph ends up looking like when I sketch it out. It takes a little bit longer, but the periods remain the same. It's still pi units, pi radians from one asymptote to the other. It's just simply shifted over by 3 pi over 2